So I'm recording now. So circle theorems, basically the principle is you have to learn the theorems and then you have to be able to apply them. And it's just about finding angles. The hardest calculation you've really got to do is 180 minus something. Right? It's, with circle theorems we're not really using trigonometry, we're not using Pythagoras theorem, nothing like that. We are just remembering certain rules, and then say you might have to subtract from 180 because of triangles or parallel lines. Or do you remember your angles within parallel lines work? Yeah, so alternate angles are equal, corresponding angles are equal, angles within parallel lines add up to 180, triangles that are created 180. Similar sort of things with circle theorems, but you have to remember certain things. Also, with circle theorems, the diagrams can get quite complex, as you have to be able to apply more than one circle theorem to calculate a set of angles within it. Okay. So what we're going to do is we're just going to go through the angle theorems that you need to know. So you are going to be drawing circles. So are you okay with drawing your circles? You've got something to draw circles with? Okay, yeah. It's the only one I've got now. If you want to. It's not very good, it's a bit loose. Okay, so we've got a circle. We have the origin of the circle is in the centre and normally called O for origin. Okay. Now, certain circle theorems you've got to know. Well, if we cross the circle through the origin, that length is called the what? The diameter. Okay. Now, when I cut a circle like this, I end up with two whats. Do you know? Semicircles, and the semicircles also have another name, which are segments. Okay. So I have two segments that are semicircles because the circle is cut by the diameter. Right. The circle theorem that we're interested in is if we go from the 2 points created, okay, on the circumference, maybe A and B we call it. If we go from A to another point on the circumference and then to B, we have another point P. Well, we know that angle APB is always, in this case, 90 degrees. So always. So that's the thing you've just got to remember. And it doesn't matter where I am. Right, if I do it anywhere, it will always be 90 degrees. Okay. And I need to switch the phone off. Right, and it's the same the other side as well, because it's the rule is angles in a semicircle, okay, equals 90 degrees. So of course the other side is equally a semicircle, therefore the angle subtended is also 90 degrees. So just to add to this one, if you cross the circle somewhere else, so not through the origin, alright, so we're not through the origin this time, but we've got points A and B. If we then go to a point P, now I think it's quite obvious that that point is not, the angle is not 90 degrees if I go to point P. So point P or point P or point P. Okay, but any ideas what you think those angles will always be? So you can't give me a value, but they're all equal. Okay, so A, P, B is always the same. Okay, in the same segment. So it's only 90 degrees if it's a semicircle. If it's not, the segment is not the semicircle, it's not 90 degrees, but they are still equal. In the same way, the other side, this angle will not be the same as that one, but they will all be equal to each other. Okay. So if I call that Q, AQB is always equal. Okay, next ones. Right. So there are quite a few, sorry, so you'll be drawing for a while. Right. So, another one that involves the origin of the circle. So, the next one we'll look at, okay, is to do with the tangent to a point. So if I draw the tangent to a point, so I would have the point where the tangent is, I don't know how good my tangent is, but the important point is that if you go from the point of the tangent to the origin of the circle, the angle with the normal, this is called the normal, and this is the tangent, is always 90 degrees. Okay. So the angle between, so we'll call that point P, between the tangent and its normal is 90 degrees. So that's not obviously an angle with the curve of the circle, it's an angle between those two straight lines. Okay, easy one. Let's move on. Another circle. Okay, this time it's sticking with that tangent theme. If we have a tangent, okay, and we draw another tangent that's not parallel to the other one, okay, we've got the 2 points and we've got the point where they meet. So A, B, well, that point P. We know that the distance AP is equal to the distance BP. Now, one thing you need to know, okay, with questions like this, if in a question they say the line BP extended, blah, 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 that has another point on it, do you know what that might mean? No? No idea? Well, the line BP extended, B to P is that line, but then we might have to carry the line on to another point, for instance. So they might say the line BP extended has a point M on it or something like that. But when we come out of the circle, we could say the line, if line BP is extended, it means it carries on past. Okay. So that's just a note that comes up and people don't quite understand what it means. Right. Okay. Next one. If we go from 2 points, A and B, on the circle, and we have another point on the circumference of the circle, if we go from A to the origin to B, an angle is formed. Okay. So if we go from A to B, an angle is created. If we then go from A to P to B, we get a different angle created. Right? So we've got an angle there, and we've got an angle there. Now the rule is that AOB angle is 2 times angle APB. So we double that angle. So the angle at the centre is twice as big as the angle at the circumference. Sometimes here it's called the Star Trek rule because of that symbol. If you put that directly above it, it kind of looks like, well, it's a delta shape which is used in Star Trek for anyone that watches it. Now that, just to follow on, it does apply, obviously that angle we've said before does not change anywhere in the same segment. So if you remember, we drew a line between A and B, this angle will not change. If I move P around, so that one will stay the same. But what will have to be taken into consideration, guys? Can you tell me? So I've got A and B. Any thoughts? So if I go from A to here, I get an angle. So we know that if P is anywhere above A and B, the angle is the same. But what happens, do you think, if we go below instead? So if we've got this angle and then this angle,
the opposite way around.
so what do you mean the opposite way around?
The one circumference is twice the one.
Well, that's that way around. Oh no, sorry, the centre is twice. So you think that one's twice that one? Well, does it look it? No. Pardon? They're not the same, no. Well, just saying it's less than doesn't give us much of a rule to consider. So you think it's the same thing? Well, the thing is, if it was the same, then that angle would have to be the same as that one, and it's not. We've said that. Unless A and B are on the diameter, then it would be, but
Could they be equal to 180?
not necessarily. I see what you mean. But well, actually, what we do is it's not this angle that we have to consider, okay? It's this angle instead, okay? So this angle with this one. So it's not, don't look at the shape and think, oh, I have to look at that one and that one, okay? So if it's underneath like this, this one, if this is A, this is 2A again. So that's double, but the one inside is not. Okay? But you do know this one and this one add up to what?
360.
360, yeah. So if you're given this one and asked to work out that one, which they do to try and trick you, well, not trick you, but make you think more, don't say that one's double that one. You have to work out the other side. Okay, this one's easy enough, right? So if that's A, that's 2A, that's fine. So whatever method you have for remembering that.
So we have to work out the 2A first.
If you're given this one, if you're given that one and have to work this one out, you know that one and have to go. It depends which way round you're asked to do it. Okay. All right. So one final one that we will go through is the ones with parallel lines. Right. So if you have another circle, if we were to draw lines across, and then join them up, so we know that this line is parallel to that line.
I was going to ask if the two lines have to be parallel.
Yeah, yeah, they're parallel. Okay. So again, you know all the rules to do with parallel lines. You know, angles being equal, right? And if those two are equal, and obviously these ones in the middle therefore have to be equal. If all three, so mine it looks pretty the same, but if all three angles in a triangle are equal between two triangles, what do you know about the two triangles? In this case they look congruent, but they're not always going to be congruent. What's the other word I'm saying?
They're similar.
They're similar, yeah. The two triangles are similar. So mine obviously looks like they're exactly the same, but if you were to draw it differently, I guess, excuse me for putting it above and not the right place, but if I were to draw my lines in different places, so I've got, let's say, that one and then a longer one. Now this triangle is smaller, you can see it now, but we know that angle and that angle are the same because of parallel lines. We know this angle and this angle, and therefore this one and this one are the same. So the triangles are different sizes, but we know they're similar because of the thing we know about angles within triangles, similar triangles. Okay. Any questions on any of those at the moment? Anything we want to go back to have a quick look at and ask? No? Okay, so the work that you are going to follow on through then, right? You are looking at from page 550 onwards, right? So it's page 550 all the way through. There's one that we haven't covered, but I'll let you go through that yourself. Should be easy enough to read. So page 559. Right, you've got all those exercises on all the different circle theorems and applying them and using them. Right, now what I'm going to say is I would like you to sketch the diagrams as they get a little bit more difficult. So for instance, if you are looking at exercise 27A.1 on page 550, I don't expect you to draw the diagrams for question 1, for instance, but question 1A, B and C, but when we start getting to question F, for instance, when it starts getting a little bit more complex, and then questions 2, 3, 4, I would like you to start drawing the diagrams, because you need to start getting into the habit of actually probably highlighting the circle and identifying the rules by highlighting certain lines. You will need to do it when you see past paper questions. You'll see what I mean when I give you some past paper questions on this. So draw the diagrams when they start getting a little bit more involved. Alright? And remember to label any angles in the diagram. Once you've found the angles, label them. Alright? Yeah?
We do all of them or every other?
I think you should do all of them because you need the practice. They're not hard, but it does take practice to identify the rules and things. So, yeah, do them all in this case. Alright?